Okay, maybe let's try to get it started. Welcome back, everyone. This is the online session number 2 for the WeCan' 2022 workshop. And we have our first speaker is Gopinath and Rajendiran. I try my best to pronounce it, but I guess it's not entirely accurate. But so Gopinath is from this private company, startup company called Ashia, and he is a researcher and data scientist at the company. Before that, he has worked as a research associate as a CSR Center Scientific Instrument Organization. And his work is focused on non-intrusive load monitoring using deep learning algorithm. And I think that will be the topic he will cover today in his talk. Okay, so without further ado, let's welcome Gopinath. Okay, thank you very much.
Yeah, hello everyone. So I'm Gopinath Rajendiran. So my talk is on non-intrusive load monitoring. Yeah, promising path to the society for responsible energy utilization and sustainability. So we all know that the energy sector is a key sector where it consumes significant energy. So these buildings are consumes around 40% of total energy, and it emits 33% of greenhouse gases. So the energy demand is increasing gradually every year, and if it is not monitored or optimized properly, it may lead to energy crisis. So recently, I have seen some news that in Japan and Australia in this month, due to the energy crisis, people were asked to switch off some unnecessary lights and loads due to this high energy demands. So therefore, so the energy monitoring is this necessitates to monitor the loads, the energy in the buildings for reducing the energy usage and conserve energy. So this energy consumption can be reduced in two ways. One is constructing energy efficient buildings, and another approach is optimizing energy usage in existing buildings through advanced energy monitoring systems. So generally, what we do is that we measure the total energy consumption through smart IoT meters. Based on that, we pay the bill, and if we want to conserve energy, analyze how we utilize our loads, we don't have much information from the total energy which is measured in the energy bill. So therefore, we need to monitor in the load level, so that the consumer can understand their energy usage behavior, and it may lead to reduce the energy consumption. So the traditional approach is that to monitor the loads, we need to use each sensor for every loads, which is not feasible in all kind of environments, and it may lead to huge upfront cost, and it will require more space and wire arrangements for this intrusive load monitoring approach. So therefore, there is a necessity to use for how we can monitor in a non-intrusive manner. So therefore, a non-intrusive load monitoring approach has been introduced long back, but it is not much popular for the last for 10 years. But now it is a hot topic in the energy monitoring systems. So here, the non-intrusive load monitoring means that we are measuring the total energy consumption. We can call it as a aggregated energy from the main power supply point. So we are trying to disaggregate this total energy consumption into the load wise, so that we can able to understand how much each load has consumed, which will help to understand our energy usage behavior and the energy waste also. So for that, we need to capture the signatures. Which can be during the steady state as well as the transient states operation of the loads or appliances. For this, for learning the signatures, some AI based machine learning and deep learning algorithms are used to identify the loads and disaggregate the energy effectively. So this is the model, the generic model of the non-intrusive load monitoring system. So the first is the aggregated power is the sum of loads power consumption by individual devices. So what we are doing is that we are trying to extract features from the aggregated energy. That is the input, we call as an input, and we are trying to map it into output. It's called as a degree disaggregated power for individual loads. So this learning of this input to output function, we use this machine learning algorithms effectively. So this is the generic functional block diagram of this NILM system, which here the loads are there, some n number of loads are there or appliances. So first it is pre-processed the raw signals, and then the pre-processed raw signals are then from that we are extracting some useful features which can help to distinguish the loads and disaggregate the energy effectively. So, and then we are identifying the load status, whether it is on or off, and how much energy is consumed, and from that, another application may be whether it is behaving a normal or anomaly. So this is the process involved in this energy disaggregation process in NILM systems. So, and these are the NILM datasets and products. In open domain, there are many popular datasets are there to pursue, do research, and analyze the NILM systems, and also evaluate different NILM algorithms with the state of the art. So most of the, so you can see that the sampling rates can vary from very small frequency to higher frequency. So it depends on how much information we are capturing, and the higher. So we need to trade off between the sampling rate versus the performance of the NIL system, how accurate it is. So, then some of the products have been there in the market. So these are the major products in the market. So these are mostly from the review of literature. We understood that most of these products in the market is is deployed for mostly in residential buildings, where the common loads or appliances are used, which can be scaled across many houses, so that it will be easy for them to scale the business. However, still many commercial buildings or industrial buildings, it is not yet much explored by these NLM systems. So in this process, actually, we have done on a real-time case study of NLM device. We have developed an NLM device in our company in a previous work. So we have developed, we designed the PCB boards and developed from the scratch for this using the low cost system, and we carried out a field trial in the residential and commercial buildings. So the thing is, in the residential buildings, more common devices like kettle, fridge, PC, and air conditioners were monitored. And in commercial buildings, air conditioners are monitored. The scenario is that most of the works are in this literature are focused on residential buildings, and very few works were done on some similar loads, which is a key factor, and it will affect the performance of the NLS systems, because the distinguish the different loads is not much challenging, though it is challenging, but it is not much challenging. But if what happens if same kind of air conditioners, same kind of devices, let's say PCs uh, fridges, freezers, or lighting systems are there. So generally we buy same kind of or in same capacity and same make. Then it will be very difficult for the NLM algorithm to detect loads and disaggregate the energy. So we particularly focused on similar loads, like multiple air conditioners in the office environment in a commercial buildings, to focus how we can disaggregate the similar loads using state-of-the-art NLM systems. So here we developed some unique approach in this. Some features we fused some basic electrical features as well as the statistical features, and use this information to model the NLM system for energy disaggregation. So from our field trial, the case study, we note that our system was able to disaggregate the similar loads around 75 to 80% of accuracy. Uh, then from our case study, what we analyze, so there are a few research challenges we have noted we faced. One is that to design the hardware or develop the edge device, we need to focus on how much the signal should be sampled. So higher the sampling rate, we have the more information, and lower the sample, we will lose some information. So we need to trade off between the sampling rate and NLM performance, so that we can choose the appropriate hardware specifications. And further, the higher the sampling rate, we also have more data. So the data storage problem may also have if you want to transfer the data to a cloud. So these things makes we need to trade off between these criteria and factors, and the main thing is during the our case study, we know that many similar loads are there. For example, in a commercial building, we may have many lights will be there, many lights. So that will be exactly same. So we cannot focus, we cannot disaggregate much the lighting systems effectively. So, and many pieces will be there. So we cannot model each and everything. So that is the major challenge in utilizing the NILM systems in commercial buildings when compared to the residential buildings. So one more thing is that we need the pre-deployment complexity is that if you use that supervised algorithm, we need to learn individual signatures of each loads. So which is very complex, and it is impossible in a real time. So what we did is that So we installed some plug-in sensor for since we focused on the high power consumption device, which is air conditioners. So we deployed plug-in sensors and we are also measuring the aggregated energy. So from this, we need to wait for so combinations. So we cannot implement in a short time, but we need to wait for some at least a week time so that the combination of loads signatures can happen naturally. So one more thing is that so this is the problem in the supervised learning, and if we adapt some unsupervised learning approach, it will take further time. So it will take few weeks to months as per the market devices, which is mentioned that yeah, unsupervised learning algorithms, it's take a few weeks to months time for learning the devices. But the thing is that the changes in the monitoring environment also will affect the NLM system. But in case of unsupervised learning, yeah, it is able to adapt because of its nature. However, supervised learning algorithm, so it won't what recognize it. So we need to retrain or need to adapt some more approaches for that for the changes in the monitoring environment. So the benefit is that the real-time feedback of appliance usage, which will help the user to avoid the waste energy consumption, and it changes the user energy behavior, and the ability to break down the bills, which will affect significantly on the conservation point of view. And we also can able to some features like controlling the loads with the use of NILM will significantly improve the energy consumption, and we can avoid the energy wastage significantly. And the thing is that the consumers will be more responsible if we have a system like NLM. We can instantaneously we can monitor at the load level, and this awareness on energy utilization will lead to sustainability. So the future perspectives of NLM is that so though it is having some promising yeah, technology, it is a promising technology, and it can also having some more applications which is started exploring by the researchers. One is the anomaly detection and predictive maintenance. Since the NLM is providing the energy at the load level, can we able to use that information to detect the anomaly operation of the loads in buildings, so that we can able to stop the abnormal consumption, which is increasing the energy cost of the bill. So the some few attempts have been made in this direction, but still many improvements needs to be done for this anomaly detection from the NILM results. Then the effective detection of anomalies in the loads will lead to predictive maintenance in a buildings, which is much effective in energy monitoring systems. And another application is the load forecasting. So from this NLM loads, the energy consumption of the individual loads, whether we can forecast it for short term as well as the long term, which is helpful to know the demands of the buildings, so we can scale it into the regions wise or uh, or uh, or apartment wise or building wise, how we can forecast the demands of the buildings effectively. And another application is in distributed energy resources. Whether because some buildings may be so many energy resources may be used, solar or wind, and the combination of that. So whether NILM can able to disaggregate the energy resources, like how much solar energy has been used for the loads, or how much energy is from the conventional energy. So this will help in the distributed energy resources network effectively. So the conclusion is that there are a significant progress has been made in real-time implementation of NLM systems due to smart metering and IoT. So another thing is that effective implementation of NLM would impact in a big way in the residential sector, and the energy conservation and the energy awareness about the energy utilization will be uh, brought out to the society level. And there are more scope to improve the NLM algorithms, and incorporating these applications into the NLM systems would effectively change the energy sector. And we need to bring more awareness on this at the society level. And one more thing is that the NLM product should be cost effective, and it should guarantee some significant amount of cost savings in their electricity bill. So these are my conclusions.
Okay.
Yeah, thank you. Any
Okay.
questions are welcome.
Okay. Thank you. Thank you, Gopinath. I think we have a time for a couple of questions. So, Noman, you want to go ahead?
Yes. So if I remember correctly, the first paper like that really formalized the NILM non-intrusive load monitoring was in 2014 NILM TK paper. And
Yeah.
we have known the potential of NILM for all these applications that you mentioned since then. But do you have any statistics on adoption of NILM TK by like general public? Like, for example, you worked on like with a company that works on a product for NILM TK. So do you have any statistics on like how many such devices were deployed and how realistic it has been in terms of mass adoption? Because on research, and we know that like there are a lot of different avenues where NILM TK and in general the non-intrusive load monitoring can be really helpful.
Yeah. So from my knowledge, I think the NLM products, we did at the research level, and we developed and made a field trial and transferred the technology. So it is in the process of in the marketing through some other third parties. So that is from our side in India, and some and in India, I think one more company is there, Bixley, in Bangalore. I think it is scaling. It is deploying devices in. I think in residential sectors as well as some hotels like that, and and in the globally means in US, the Sense product is very famous, which is scaled massively in residential sectors. It's cost around some $1,000. So the thing is that there are many challenges is that, but it did not scale up much in largely. Maybe that there are a lot of practical limits in the NLM system, so that need to be addressed because because the changes in the monitoring environment, that is the biggest challenge, and some small loads, or there will be always some unknown loads will be there, which will affect the system. So that's what so the challenges need to be addressed for in a large scale, and for in a public, the cost need to be come down to adapt in households. I think if it is if the system is effectively modeled and developed, it can be a part of our normal energy metering, smart metering. That would be the ultimate goal of this NILM.
Thank you.
Okay. Yeah, thank you for the Q&A. So because of time limit, maybe we'll move on to the next talk. Thank you, Gopinath.